All right, each section does have a program, so there's 4 problems here, so 4 programs. Grab a calculator if you want one.
Another day, another different.
And it's just like last chapter where all we care about at the end of the program is the p-value. So, at the top, if the p-value comes out smaller than alpha, we're going to reject the whole. And if the p-value comes out greater than alpha, we're going to fail to reject the whole. Here you go, Maya. No, that's homework. Where did I just put these? There you go. Okay, so just like before, we'll start by rewriting the claim, and then we'll be looking for whether it matches up with section 8.1, 8.2, 8.3, or 8.4. So a guidance counselor claims that high school students in a college prep program have higher ACT scores than those in a general program. The mean ACT score for 49 high school students who are in a college prep, blah, blah. So this is it. He doesn't say the word mean in here, but then it refers back into means. So we are talking about the mean ACT score. So the claim then that the mean of the college prep program, how would those scores compare to the general program? Greater than. All right, so there's our claim. So if we write it as a difference, mean of the college prep minus the mean of the general is going to be greater than 0, making that the ha. The whole will be less than or equal to. So now you've got to decide, because it's means, you've got one of 3 sections. First thing you should check are your samples. Are they independent samples or dependent samples? Independent means they're totally different groups. Dependent means they're the same group before and after. What's the case here? Independent. So now it's large sample or small sample? Large sample. So we're at the very first section, which was the Z's. So this program, because it's large, independent, the program here is going to be a 2-samp z-test. And it might be helpful to pull the information out and put it in little table form. So I'm going to put college prep and then general, because there's 3 pieces of information for each one. So college prep, the sample size was 49. The average was 22.1. Standard deviation was 4.8. And then for the general program, sample size was 44. Mean was 19.6. And standard deviation was 5.4. Not necessary, it's just going to make it easier for the program. Okay, so go ahead, same place as before. Stats.
Oh yeah, we don't even have to use the
Alpha?
Yeah.
Nope, we're not making a graph or anything, so go over to tests again. And now this time we're looking for a 2-samp z-test, which is number 3. Okay, so the first thing it wants are standard deviations. We don't have the population ones, but we have the sample ones. And what they're considering 1 is what we wrote first here. So because we wrote college prep minus general, the college prep is going to be considered sample 1, the general is going to be considered sample 2. So everything with a 1 is coming from the college prep. So, well, it looks like I did this yesterday. So 4.8, 5.4, mean 1 is 22.1, N1, mean 2, N2, and again it's the Ha sign, so the Ha has a greater than, so that's all the way over. Calculate, and again all you want off of that screen is the probability value, the P. So P equals 0.009. And now how does the P compare to alpha? Less than. If P is less than alpha, we're going to reject the HO. And in this case, making the claim true. Okay, next one. Okay, test the claim at 1% that the mean annual incomes in Delaware and Greene counties are the same. A random sample of 17 residents of Delaware County has a mean annual income, blah, 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 and then same thing for Greene. So, the claim is about means. So we got the average from Delaware County, and yes? Oh, you know what, because I cut it off. Because it was, given above, all the directions for the set of problems. Yeah, these are all normal, but good call. Delaware, and it says they are the same. So that means equal. So then our difference so our claim is the HO this time. The HA is not equal to 0. Okay, so first thing again, because it's means, are these independent samples or dependent samples? So do they completely overlap or is there no overlap? No overlap. You got Delaware County people and then Greene County. So this is independent. And then it's large or small? Small. So independent small samples, normally distributed, is going to be a, take a guess, 2 SAMP t-test. So I will write the Delaware stuff, the Greene stuff, and again, just so Delaware sample 17, mean 31,200, standard deviation. Now Greene County, we had a sample of 18, mean 29.5. and standard deviation 73.75. And it's going to be very similar, but with one extra step in here. So 2 SAMP t-test is 4. I really like whoever made this program better because they put all the sample 1 stuff here and then all the sample 2 stuff, where the other one kind of jumped back and forth. Yeah. I'm going to say 2 different programmers did these programs, because why wouldn't you just stick all the sample 1 stuff in a row? So, HA is not equal to, pooled or not pooled? Do you remember how to tell? Assume the population variances are equal. What does that mean? Pooled. If you remember from the notes. If they're not equal, it's not pooled. That has to be given. So we are pooled with a yes. Calculate. And again, the p-value. High probability, 0.512. So that is greater than alpha. So we're going to fail to reject the Ho. And then what are we saying about the claim? Neef is correct. Okay, 17. The table shows the gas mileage of 8 cars with and without using a fuel additive. At 10%, is there enough evidence to conclude that the fuel additive improved gas mileage? And again, I cut off the directions that said everything's normally distributed. So are these independent samples or dependent samples?
Dependent.
Dependent. It's the same cars without the additive and then with. So these are dependent samples. We only had the one section on dependent, and remember we used t-values there. But this one is not going to be a 2-sample t-test, because remember when we did the 3 lists, we brought it down to the 3rd list and ran our 1-bar stats. So really all it's going to be is just a regular old t-test on our list 3 information. So I'm going to say t-test on list 3. So let me write down the things you're going to have to do first, just like, it's kind of like doing it by hand, except you don't have to do the plug and chug. So the first thing you're going to do is, in list 1, you can put the without additive. In list 2, you're going to put the with additive. And then list 3, you're going to go L1 minus L2. And then run 1-bar stats on this list. We didn't write the claim yet, but if you can, well, yeah. Go ahead and get to the list 3, and then we'll go back and write the claim. So clear out 3 lists. Well, I've got mine in here. I'm going to leave mine. I was practicing, but I think I put them in the opposite way. I did. So I'll just fix mine here to say and then I'll show you my 1-bar stats to make sure you got to the same screen. You didn't get that, well then it's you made a mistake putting numbers in. Let me check. One digit off. Everybody good? Okay, we've got to write the claim first before we can go in and run the program. So our claim, we are comparing the average without the additive compared to the average with the additive. So what sign belongs between those? If it says the fuel additive will improve gas mileage, so with is going to improve. So what do you want between here? Oh, less than. The with will have a higher gas mileage than the without. And then we really don't have to do the subtraction on this one. Without minus with, less than 0 for the ha. The ho. The mean and the S. Yep, but I think when you run one of our stats, it throws those numbers into the program. When we go there, we're going to see those numbers substituted in. I'm pretty sure, but we'll write them down just in case. So the mean, negative 1.125, and the S, 0.871. But I don't, like I said, I'm pretty sure it just sticks all the numbers in all of the programs, so when you go to it, it's going to be there. So we're going to run t-test. Not two-samp, just regular t-test. So stat, over to test. T-test is number 2. The mu0, that's from the hoe. That's 0. Sample mean, notice it matches what we got. The S matches what we got. Sample size, it counted already. So it really substitutes everything in when you run the one bar stats. But we got to fix this. We have a less than, so that's the middle one. Oops, drop down here. The middle one, and then calculate. So the P is 0.004, which is smaller than 10%. So we're going to reject the hoe, and the claim is true. And then I obnoxiously put the last one sideways here. I don't know why I didn't put it on the back. Because there's not a lot of room. All right. In 1990 study of 1,539 adults, 520 said they used alternative medicines, for example, folk remedies, homeopathy, in the previous year. In a recent study, and recent meaning probably around 1997 when the book was published, of 2,055 adults, 865 said they used alternative medicines in the previous year. Can you reject the claim that the proportion of adults, so it's not talking about a mean anymore, it's talking about the percentage of adults using alternative medicines has not changed since 1990. So the claim, the proportion, we're comparing 1990 to recent. And if the claim says that it has not changed, what are you putting in there? Equal. So 90 minus recent equals 0, making that the hoe. The ha not equal to 0. Okay, proportions. We should be checking the size. Remember, we need the number of successes and failures of both to be 5 or more. Are we good with that? 520, 865. The other ones are going to be bigger, so check for normal is good.
When you do that,
Yep.
so it's like you take the sample size, which is like the 1,539.
Yep.
And you would multiply that by 520 out of 1,539.
Yep.
So you're just going to get 520.
Yeah. So really that check is really the number of successes and the number of failures. Both have to be greater than 5 for both samples. Okay, the test is the heck's it called again? 2 prop Z test. And there's only 4 values. The sample size and the number of successes for each of the 2 samples. And remember, if they give you the percentage, you got to multiply to get back to the number of successes. So, that test 2 prop is number 6. 4 numbers you got to put in. And X is, remember, number of successes. So if it's the percent that's given, you got to multiply and round to the nearest whole number. So we got 520. And our sample 1 is what we wrote first, so that's the 1990 information. And the recent is our sample 2. 865, and we've got a not equal to, What's that probability? Some of you missed this on the last test. Didn't catch it anyway.
4.16
Times 10 to the negative 7. These are probabilities. They cannot be over 1. So when you see 4.16, you better look at the end of the line and pick up on the fact that this is in scientific notation. So P equals 4.16 times 10 to the negative 7th, which is really small. So we're going to reject the hoe, making the claim false. So it has not remained the same. Okay, I have a worksheet with them all mixed together. And again, I forgot to put on that everything is normally distributed. So, because I cut everything up, but then I forgot to write it at the top. So all are normally distributed. Do all of them.
Not assume they're normal,
Assume they are all normal.
and just not do any of them.
Yeah.
Why is the D one?
No, I can have those back today. Good call.
I don't know if I want to see those. What's my worst test of the year? What's not my go to that? Oh, I only have 1.0. Yeah, right there.
I gotta go set up my recording real quick. I forgot to hit, then I'll be right there.
I finished my notes already.